When trying to estimate a population proportion, we have a few methods for using a sample proportion to estimate a population proportion. There are three main ideas that should be known and understood. They are: the sample proportion is the best point estimate of the population proportion. We can use a sample proportion to construct a confidence interval to estimate the true value of a population proportion, and you should know how to interpret a confidence interval. What is a confidence interval actually trying to say? And you should know how to find the sample size necessary to estimate a population proportion. So let's look at some definitions. A point estimate is a single value or point used to approximate a population parameter. And again, the sample proportion is the best point estimate of the population proportion, P. The notation for a sample proportion, if you're given it, is P with this little hat on top of it, which is sometimes called just P hat. So the sample proportion is P hat. Confidence interval is a range or interval of values used to estimate the true value of a population parameter. The notation of a confidence interval is sometimes used as CI. That looks like a lowercase l, but that is a capital I, so CI. Next is confidence level. The probability 1 minus alpha, often expressed as a percentage that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. It's possible that the confidence level will actually be abbreviated as CL. Now, be aware when it comes to the confidence level that the percentage of the confidence level is how confident we are that the true parameter is located in the interval. It does not mean that the percentage of the values are in the interval. Now, that sounds kind of confusing, so let me clarify. When we have a confidence level, when we say we are 95% confident, or 90% confidence level is what we're looking for, that is how confident we are that the true parameter, whatever it may be, is located in the interval. So between some number and another number, we're 95% certain that it's there. What it does not mean is that 95% of the values are located in the interval. It just means that we are 95% confident, or however confident we're trying to be for a particular question, that the true parameter is in the interval somewhere. Next is critical value. The number on the borderline separating sample statistics that are likely to occur from those that are unlikely to occur. The number z sub alpha over 2 is a critical value, that is a z-score with a property that separates an area of alpha over 2 in the right tail of the standard normal distribution. So when you have z sub alpha over 2, that is the critical value. And last, margin of error, the maximum likely difference with a probability of 1 minus alpha between the observed sample proportion, p hat, and the true value of the population proportion, p. The notation for margin of error is capital E, and you can compute the margin of error for proportions using this formula here: z sub alpha over 2, the critical value, times the square root of p hat times q hat over n. And q hat is just 1 minus p hat. So make sure that p hat, q hat, and n are all underneath the square root when computing the margin of error.